CIET NCERT presents the audiobook Exploring Society, India and Beyond, textbook of social science for class 6.
Chapter 1, page 7. Locating places on the Earth. The globe of the Earth stands in space, made up of water, earth, fire and air, and is spherical. It is surrounded by all creatures, terrestrial as well as aquatic. Aryabhat, about 500 CE. Here we see the picture of a map. The big questions. 1. What is a map and how do we use it? What are its main components? 2. What are coordinates? How can latitude and longitude be used to mark any location on the Earth? 3. How are local time and standard time related to longitude? Page 8. Imagine that you are visiting a city for the first time. How would you find the places you want to visit? You might ask a local person for help, or you might look at a map of the city. In previous grades, you learned a little about maps, and in this chapter, we will study them in more detail. Let us play a game. Examine the map of this small city given here on the page. Figure 1.1. Imagine that you just got off a train at the railway station and you want to visit the bank marked on the map. Which way would you go? Are there other possible ways? Can you locate the public garden, the school, and the museum? If you want to proceed from the bank to the market, which way will you go? This is where a map comes in handy. A map is like a treasure guide. It shows you where things are and how to get to them. Notice the 4 arrows in the top right corner of the map. We will soon see how they point to some specific directions and make maps even more helpful. On page 8, towards the end, we have the picture of a map of an imaginary small city. It shows various places like railway station, school, hospital, market, Nagar Panchayat, apartments, bank, museum, etc. Page 9. Let's explore. On the map in figure 1.1 given on page 8, 1. Mark the hospital. 2. What is the meaning of the blue-colored areas? 3. Which is farther away from the railway station, the school, the Nagar Panchayat, or the public garden? As a class activity, form groups of 3 or 4 students each. Let each group try to draw a map of your school and some of the streets or roads that lead to it, and a few neighboring buildings. At the end, compare all the maps and discuss. A map and its components. From this simple example, we understand that a map is a representation or a drawing of some area. It may be a small area, a village, a town, etc., a bigger area, say your district or state, or a very large area, like India, or even the whole world. In a map, you look at the surface as if you are viewing it from the top. An atlas is a book or collection of maps. As you will discover, there are several kinds of maps. Physical maps, which mainly show some natural features such as mountains, oceans, and rivers. Note the example in figure 5.2 in this textbook. Political maps, which show details of countries or states, boundaries, cities, etc. For instance, a map of India with all its states, union territories, and their capitals. Thematic maps, with a specific kind of information. Examples include figure 6.3 and figure 8.1 in this textbook. In addition, there are 3 important components of maps: distance, direction, and symbols. You have already experienced the first 2 while navigating the map in figure 1.1, page 10. Let us now define them more precisely. Have you ever wondered how a huge place can fit on a small piece of paper? It is all thanks to the map's scale. Let us go back to our map of a small city, figure 1.1. Each centimeter on the map, as printed here, represents a certain distance on the ground. Let us suppose it is 500 meters. We say that the scale is 1 centimeter is equal to 500 meters. Now, turn to the map of India in figure 5.2 in chapter 5 of this textbook. The scale is represented in the bottom left corner by a ruler with 500 written above its length and kilometer, that is km, on the side. It simply means that this ruler, which measures 2.5 centimeters in the printed map, corresponds to 500 kilometers on the ground. So the actual distance between 2 points represented on the map depends on the scale that the map is using. Let's explore. Draw a simple map of a school's playground. Let us assume it is a rectangle 40 meters in length and 30 meters in width. Draw it precisely with your ruler on a scale of 1 centimeter is equal to 10 meters. Now measure the diagonal of the rectangle. How many centimeters do you get? Using the scale, calculate the real length of the playground's diagonal in meters. On the bottom left of the page, we have the picture of a compass. Let us return to the 4 arrows at the top right of the small city's map. They point to 4 directions, which are north at the top and, moving clockwise, east, south, and west. These are called the cardinal directions, also cardinal points. Other than these, intermediate directions are also used: northeast, NE, southeast, SE, southwest, SW, and northwest, NW. Most maps simply have an arrow marked with the letter N, which points to the north direction. Page 11. Let's explore. Consider the map of the small city again. Identify the correct and incorrect statements in the list here. 1. The market is north of the hospital. 2. The museum is southeast of the bank. 3. The railway station is northwest of the hospital. 4. The lake is northwest of the apartment blocks. Taking your school as the starting point, do you know approximately in which cardinal direction your home is located? Discuss with your teacher and your parents. Symbols are another important component of maps. Our map has small drawings of actual buildings and a few other elements. But there would not be enough space on the map of a large city or a country to draw them all. Instead, a symbol is used to represent these features. Symbols for different kinds of buildings. For instance, a railway station, a school, a post office, for roads and railway lines, and for natural elements such as a river, a pond, or a forest. In that way, numerous details can be shown in the limited space available on a map. To make maps more easily understood by a variety of users, map makers use specific symbols. Different countries use different sets of symbols. The Survey of India, a government body, has fixed a set of symbols for maps of India or parts of India. A small selection of them is shown in figure 1.2 on page 12. Let's explore. Draw a rough map of your locality or your village, including your home, school, and a few other important landmarks. Show the cardinal directions and use a few of the symbols shown in figure 1.2 on page 12 to mark some important features. Page 12. On the top of the page, we have a picture showing a selection of symbols commonly used in maps. The symbols represented are for railway line, broad gauge, meter gauge, railway station, roads, metalled, unmetalled, boundary, international, state, district, river, well, tank, canal, bridge, temple, church, mosque, chhatri, post office, post and telegraph office, police station, settlement, graveyard, trees, grass. Mapping the earth. Mapping the earth is a little more difficult because our planet is not a flat surface. It nearly has the shape of a sphere. We say nearly because it is not a perfect sphere, but is slightly flattened at the poles. However, in practice, we will consider it to be spherical. Representing a sphere accurately on a flat sheet of paper is not possible. To understand why, peel an orange in such a way that you have just 3 or 4 large pieces of the skin. Then try and flatten them on a table. You will see that you cannot do it without tearing them at the edges. Now consider a globe, which is a sphere on which a map is drawn. This may be a map of the Earth, the Moon, the planet Mars, the stars and constellations in the sky, etc. The physical object, like the one shown in the drawing on the next page, is a sphere that is generally made of metal, plastic or cardboard. Page 13. Here we will study the globe representing the Earth's geography. Because the globe and the Earth have the same spherical shape, the globe will better represent the geography of the Earth than a flat map. On the right side of the page we have the picture of a boy and a girl who are exploring a globe. Let us now explore some of its features. A. Understanding coordinates. Imagine a big market in a city or town with neat rows of shops, all the same size. You want to meet a friend at a stationery shop inside the market, but your friend does not know where the shop is. So you would give directions like, meet me at 6 p.m. at the 7th shop in the 5th row from the entrance. This will allow your friend to precisely determine your location. Now consider a chessboard. To record moves by advanced players, letters are placed alongside the main pieces from A to H, as shown in the image on the right, and numbers from 1 to 8 in between the two sides. This simple system allows players to mark each square and record every move. Here the white side has just opened the game by moving the queen's pawn 2 squares forward, a very common opening. So the pawn is said to have moved from d2 to d4. Let's explore. Using the same terms, write down your move if you play black and respond with the same move. Page 14. The system used in these two examples may be called a system of coordinates. Thanks to their 2 coordinates, the stationery shop as well as the chess square on the chessboard can be precisely determined. A similar system of coordinates is used in the world of maps to determine the location of any place on a map. Let us see how this system works. B. Latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. Rotate the globe. While it rotates, the fixed points at the top and bottom are the 2 poles. Halfway between them is the equator. Note the circle marking it. It's given in figure 1.3. Imagine that you stand on the equator and travel towards one of the poles. Your distance from the equator increases. Latitude measures this distance from the equator. At any point of this travel, you can draw an imaginary line that runs east and west, parallel to the equator. Such a line is called a parallel of latitude, and it draws a circle around the Earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked by the parallels of latitude grow smaller as we move northward or southward. Figure 1.3. Latitudes are expressed in degrees. By convention, the equator is latitude 0 degree, while the latitudes of the 2 poles are 90 degrees north and 90 degrees south respectively. This is noted as 90 degrees N and 90 degrees S. There is a connection between latitude and climate. Around the equator, the climate is generally hot. It is also called torrid. As you travel away from the equator towards one of the two poles, in other words, as your latitude increases, the climate becomes more moderate or temperate, and closer to the north or south pole, the climate grows colder or frigid. You will learn in science why this is so and also why we experience different seasons in the course of a year. Page 15. On the top of the page we have figure 1.3 depicting a globe showing both parallels of latitude and meridians of longitudes. C. Longitudes. Imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe. You will see that instead of passing through Europe and Africa, you could just as well pass through Asia. The distance would be the same. These lines are called meridians of longitude. Refer to figure 1.3. They are all half circles running from one pole to the other. You will also learn in science that the Earth spins on its axis. To put it simply, let's place a desk lamp a little away from our globe, focused on it, and imagine that this is the sun illuminating the Earth. Page 16. Slowly rotating the globe eastward, we can note that for some places on the Earth it is morning, while for others it is midday, evening, or night. When it's breakfast time in one country, it's lunch time in another, and in a third country people are fast asleep. That is why, by measuring the longitude of a place, we will also be measuring the time at that place. Let us see how. To measure longitudes, we need to define a reference point called the prime meridian. Refer to figure 1.3 on page 15. It is also called Greenwich meridian because in the year 1884, some nations decided that the meridian passing through Greenwich, an area of London in England, would become the international standard for the prime meridian. It is marked as 0-degree longitude. Just as latitude is a measure of the distance from the equator if you travel towards one of the poles, longitude is a measure of the distance from the prime meridian if you travel along the equator. Longitude too is measured in degrees, westward or eastward. It increases in value from 0 degree to 180 degrees with the letter W or E added. For instance, using round figures, New York's longitude is 74 degrees west, written as 74 degrees W, while Delhi's is 77 degrees east, written as 77 degrees E, and Tokyo's is 140 degrees east, written as 140 degrees E. Don't miss out. As you can note on the globe of meridians of longitudes, 180 degrees west and 180 degrees east are the same longitude. So, this longitude is noted 180 degrees, omitting the letter W or E. Latitude and longitude together are the two coordinates of a place. With them, you are now able to locate any place on Earth. You can now understand a statement such as Delhi lies at 29 degrees north latitude and 77 degrees east longitude. These values are rounded off, not exact. Figure 1.3 on page 15 shows the parallels of latitude and the meridians of longitude together on the globe as blue lines. Page 17. All these lines together constitute a grid for the globe. They are also called grid lines. Let's explore. If the globe or atlas in your class has well-marked latitudes and longitudes, try to note down approximate values for the latitude and longitude of 1. Mumbai, 2. Kolkata, 3. Singapore, 4. Paris. On the page we have figure 1 point show, which depicts a sketch showing how the prime meridian divides the Earth into the western and eastern hemispheres, while the equator divides it into the northern and southern hemispheres. Don't miss out. The Greenwich meridian is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own, figure 1.5. It was called Madhya Rekha or middle line and passed through the city of Ujjaini, today Ujjain, which was a reputed center for astronomy over many centuries. Varahamihira, a famous astronomer, lived and worked there some 1,500 years ago. Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or prime meridian. The Ujjaini meridian became a reference for calculations in all Indian astronomical texts. Page 18. On the page we have figure 1.5 showing the Ujjaini prime meridian, used in ancient Indian astronomy. Cities marked with a circle are mentioned in astronomical texts as being on this meridian. The modern name is given after the oblique bar. The map shows a few ancient Indian cities close to the Ujjaini meridian. Some are very close to it, while others are a little away. That is because measuring longitude required accurate timekeeping, which was not as precise then as it is today. Page 19. On the page we have figure 1.6, a map published by the Survey of India, showing the country's outline along with a few parallels of latitude and meridians of longitude. India's latitudes extend approximately from 8 degrees north to 37 degrees north, and longitudes approximately from 68 degrees east to 97 degrees east. The two colors have been added. Page 20. Understanding time zones. Let's make the globe rotate again from west to east. That is how our planet spins around its axis, making a full turn every 24 hours. A full turn is 360 degrees, so this means 15 degrees per hour. 15 multiplied by 24 is equal to 360. Let us now mark the meridians of longitude every 15 degrees. Moving eastward from the prime meridian, we get 0 degree, 15 degrees east, 30 degrees east, 45 degrees east, and so on every 15 degrees up to 180 degrees east. It is the same as adding 1 hour of local time with each meridian. If it is 12 p.m. or noon at Greenwich, it is 1 p.m. local time at 15 degrees east, 2 p.m. at 30 degrees east, and so on. But going westward, it is the other way round. 11 a.m. local time at 15 degrees west, 10 a.m. at 30 degrees west, etc. Figure 1.7 on the page is a graph which shows longitudes at the bottom and the local time at the top, with reference to the prime meridian at 0 degree. Each color is a zone of 15 degrees centered on a meridian. Page 21. Let's explore. Two friends, one sitting in Porbandar, Gujarat, and the other in Tinsukia, Assam, are speaking on the phone late afternoon. The latter remarks that the sun has set in Assam and it's now dark. The former is surprised and says, "But it's still full daylight here." Explain why, and as a class activity, calculate the difference in local time between those two cities. Hint: for now, consider the difference in longitude between Porbandar and Tinsukia to be 30 degrees. Later you can find out the precise value. The same method can be used to calculate the local time of any place on the earth, but it would not be convenient for a country to use many local times. That is why most countries adopt a standard time based on a meridian passing through them. Indian Standard Time, IST, is 5 hours 30 minutes, also noted 5.5 hours ahead of the local time at Greenwich, called Greenwich Mean Time or GMT. Let's explore. Return to the two friends sitting in Gujarat and Assam. Use this example to explain the difference between local time and standard time. All these standard times are organized in time zones, which broadly follow the zones of 15 degrees in the graph, figure 1.7. But let us consider the world map given here, figure 1.8. We can see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time and therefore tend to follow international borders. The numbers written inside some countries are the numbers of hours to be added to GMT to get their standard times if they have a positive sign, or subtracted from GMT if they have a negative sign. Page 22. On the top of the page, we have figure 1.8, which is a world map of the time zones showing the standard times with respect to GMT for a few countries. Note that international borders are approximate, not exact. Don't miss out. From the above explanation, it may seem as if every country has one standard time. That is not always the case. Some countries like Russia, Canada, or the USA are too large to have a single time zone. The USA has 6 time zones and Russia has 11, which means that traveling across Russia from east to west, you will need to readjust your watch 10 times to align with the local time. Similarly, the globe in figure 1.9, centered on India, shows standard times with respect to GMT for a few countries. Finally, while the prime meridian was fixed at Greenwich, the opposite line, at approximately 180 degrees longitude, is called the International Date Line. As you can notice on the map, the +12 and the -12 time zones touch each other at this line. If you cross it by ship or plane, you need to change the date in your watch. If you cross it traveling eastward, you subtract a day, say from Monday to Sunday. If you cross it traveling westward, you add a day, from Sunday to Monday. Page 23. On the top of the page we have figure 1.9, a globe which shows a few time zones with respect to GMT in Africa and Eurasia. We said that the international date line is approximately at 180 degrees longitude, as it deviates in places to avoid dividing some countries into 2 different days. Before we move on, maps are a very useful tool to represent an area of the earth, whether small or large. The main components of maps are distance, direction, and symbols. Every place on the earth has a location which can be precisely defined with the help of a grid of latitudes and longitudes, imaginary lines running from east to west, parallel to the equator, and north to south, from pole to pole respectively. Page 24. Longitude also marks the time and defines the time zones. The international date line is located approximately at 180 degrees longitude, opposite the prime meridian. Crossing the international date line changes the date by 1 day. Questions, activities, and projects. 1. Returning to page 10 and to figure 5.2 in chapter 5 of this textbook, taking the scale to be 2.5 centimeters is equal to 500 kilometers, calculate the real distance from the estuary of the Narmada River to the estuary of the Ganga River. Hint: round off your measurement on the map to an easy number. And remember, estuary is the place where a river meets the sea. 2. Why is it 5:30 p.m. in India when it is 12 p.m. or noon in London? 3. Why do we need symbols and colors in the map? 4. Find out what you have in the 8 directions from your home or school. 5. What is the difference between local time and standard time? Discuss it in groups, with each group writing an answer in 100 to 150 words. Compare the answers. 6. Delhi's and Bengaluru's latitudes are 29 degrees north and 13 degrees north. Their longitudes are almost the same, 77 degrees east. How much will be the difference in local time between the two cities? 7. Mark these statements as true or false. Explain your answers with a sentence or two. All parallels of latitude have the same length. The length of a meridian of longitude is half of that of the equator. The South Pole has a latitude of 90 degrees south. In Assam, the local time and the IST are identical. Lines separating the time zones are identical with meridians of longitude. The equator is also a parallel of latitude. Solve the crossword given here. Page 25. Here we have a crossword puzzle given on the top of the page, which is about locating places on Earth. To solve the puzzle, you need to know when you go across. 1. Lets you squeeze a huge area into your map. 4. A convenient sphere. 5. The longest parallel of latitude. 6. The place the prime meridian is attached to. 8. So convenient to find your way. 10. A measure of the distance from the equator. Going down. 2. A measure of the distance from the prime meridian. 3. These two together allow us to locate a place. 6. What latitudes and longitudes together create. 7. The time we all follow in India. 9. These two are poles apart. 11. An abbreviation for a line across which the day and date change. Page 26. Here's a big blank space for you. Noodles. Noodles is our abbreviation for notes and doodles. Chapter 1st ends here.
Exploring Society, India and Beyond. You were just listening to this audiobook. Textbook of Social Science for Class 6. Narration, Gaurav Marwaha. Sound recordist, Manju Kumari. Assistance in production, Muhammad Shamim Khan. Directed and produced by Vimalesh Chaudhary. This audiobook is presented to you by CIET NCERT, New Delhi, India.